This is Miss Sec. This is a pre-recorded class for algebra for Tuesday, June 2nd on quadratic functions, key features of the graph. This is actually a second recording of the video because I had made a mistake in the first recording, so I'm recording it again. Today we're going to identify key features of the graph of a quadratic function using graphs, tables, and equations. I don't know why this one is here. And why you can't see the graph. Okay, here we have a parabola. The parabola is U-shaped. All quadratic functions are shaped as a parabola. The standard form of a quadratic function is ax squared plus bx plus c. The vertex is the highest point or the lowest point of the parabola. So in this case, the vertex is the ordered pair 1, -4. The y-intercept is where it crosses the y-axis. In this problem, the y-intercept is 0, -3. The x-intercepts, roots, and zeros, they all have the same meaning. In this problem, there are two x-intercepts at -1, 0 and at 3, 0. They're also called roots and zeros. The axis of symmetry is the line that divides the parabola in half. So every point on the axis of symmetry is equidistant to the axis of symmetry. So these points are equidistant to each other from the axis of symmetry. In this problem, the axis of symmetry is x is equal to 1. The minimum value is the lowest point on the parabola if it's concave up, or the maximum value is the highest point of the parabola if it's concave down. There we go. Okay, so these are the answers. Okay, the minimum value is the lowest point on the parabola, and the maximum value is the highest point of the parabola. The parabola is concave up if a is greater than or equal to 1, and the parabola is concave down if a is less than 0. So if this a is negative. So a parabola that opens upward has a minimum value when a is positive. So a is greater than or equal to 0. A is positive. And the y value of the vertex is the minimum value. The parabola opens downward has a maximum value when the value of a is negative. The y value of the vertex is the maximum value. So let's look at these examples. This is a minimum value. I can't tell you the ordered pair of the vertex because I don't see the scale on the x-axis, but I know a is positive because it's concave up. And this is a maximum value. The vertex is at 0, 1, and a is negative because it's concave down. So let's try these problems. Okay, so this is a maximum, and a is negative because it's concave down. This is a minimum, and a is positive because it's concave up, and the vertex is at 0, 1. This one is a minimum because it's concave up, And the vertex is at 1, 0. And A is positive because it's concave up. And then this is a maximum. The vertex is at negative 1, 3. And A is negative because it's concave down. Okay, now the axis of symmetry is the line that cuts the parabola in half. In this case, the axis of symmetry is at x equals 4. It is a vertical line that divides the parabola into 2 equal halves. It passes through the vertex. So this is the vertex. The x-coordinate of the vertex is the equation of the axis symmetry of the parabola. So this is the formula. So this is what we're about to practice. How to use this formula. So I used this formula incorrectly in the last video, which is why I recorded the video again. Okay, in this ax squared plus bx plus c, a is the number in front of x squared, so that's 1. B is the number in front of x, so that's negative 8. And c is the number in front of 18. So we're using this formula. X is equal to negative b over 2a. So we have x is equal to negative b, which is negative 8, negative 8 over 2 times a. So a is 1. So this is 2 times 1, which is 2. 2 times 1, which is 2. And that's equal to 8 over 2, which is 4. So the axis of symmetry is 4. Now let's find the axis of symmetry from this graph. The axis of symmetry is at x equals 4. The vertex is at 4, 2, which is the minimum value. Okay, the x-intercepts are where they cross the x-axis. So in this problem, there is no x-intercept. In this problem, there's one x-intercept. But for the past few weeks, we've had 2 x-intercepts. So it's possible to have 2, 1, or 0 x-intercepts. Okay, so I want you to pause the video and find the x-intercepts. Answer these questions. So I'll give you a minute. Pause the video, and then we'll answer it together. Okay. For this first one, we're looking for 2 numbers that multiply to negative 6, but add to negative 1. So negative 3 times 2 multiplies to negative 6. And adds to negative 1. But we're making this equal to 0. So x minus 3 equals to 0, so x is equal to positive 3. x plus 2 is equal to 0, so x is equal to -3. So these are the two x-intercepts. Now, looking at this graph, the graph has two x-intercepts, and the x-intercepts are at x equals -3 and 1. But this graph has no x-intercepts, so there's nothing for us to put. Okay, the vertex of the parabola is a point where the parabola crosses the axis of symmetry. If the coefficient of x squared is positive, then the vertex is the lowest point. It's the minimum point of the bottom of the U shape. If the coefficient of x squared is negative x squared, the vertex is the highest point in the graph and the top of the N shape. Okay, I want you to go into Desmos and graph f of x is equal to x squared minus 2x minus 8 and answer these questions. Please pause the video and answer these questions. Okay. So these are the zeros at -2 and at 4. The vertex is at 1, -9. That means the axis of symmetry is at x is equal to 1. So I can actually type that in there so you can see it. X is equal to 1. So you can see the axis of symmetry divides it in half. And the y-intercept is at 0, -8. So the vertex is at 1, -9. The axis of symmetry is at x is equal to 1. The x-intercepts are at -2 and 4, and the y-intercept is at 0, -8. Okay, today is the last class. May God bless you and your family. Thank you for this opportunity. Good luck.